Walaikum assalam. Assalamu alaikum. Okay, Bismillahirrahmanirrahim. Today we are starting the continuation of the topic nature of function. And in previous lecture we defined some important things. What are the level sets and how we can define the level sets. So just recall the previous lecture. Level set. Okay. For example, I just explained that the level sets may be the part of IC, indifference curve, and IQ, etc. Isochord. So, in case of the level sets, for example, if you have a two-dimensional space, X and Y, so it is called your level set. What does it mean? Ke you decide कि now that is a point of benchmark on which you will compare which value is greater than this level value or which value is less than this level value. Let's say we have another example, like in case of the circle, x square plus y square equal to a. This is kind of the circle equation of circle. And normally when we plot this equation of circle in four dimension or the four quadrant, so it means that x square plus y square equal to a along this around that circle. Every value x square plus y square equal to a lie on this circular value. Okay, this is basic assumption of the circular equation or equation of circle. And now how you will decide, and if we have this kind of the circle, and that circle we call it is our level set. Level set for equation of circle. Circular equation. Equation of circular equation. Equation of circle. Okay. Now for equation of circle, for let's say that we have another value, let's b here, and one value, for example c, in this direction. So it means that we can say that x square plus y square equal to a. The value of b is less than a. Am I right?
Yes.
And similarly, the value of c is greater than the value of a. So all values which are greater than the value of a, they are called upper contour. And similarly, these are called lower contour. So it means that first of all you have to decide the level sets. Clear? Either you will have the four-dimensional space, two-dimensional space, and the whatever, you will need to decide the level set, and then you can compare which values are upper contour and which values are lower contour. In this example, this is kind of the two-dimensional space, or normally when you will have this kind of the level sets, so it will be the Cobb-Douglas nature of utility or IQ. Am I right? So you can write that x square and x y function of f y equal to x lambda alpha and y beta. This is kind of the Cobb-Douglas function. And now if we compare that here it is a, so we can say that now x alpha and y beta equal to this one is a, k, all values satisfy this level sets. If these are less than this one, so it is called the lower contour and this one is called upper contour. Upper contour set. Okay. Now you need to compare. We have decided that if the upper contour set are convex, so the function is quasi-concave. Clear? And if the lower contour set are convex, the function is quasi-convex. So now convex means any linear combination in that region, right? Any linear combination. For example, this is your point B and take for example B dash here. So linear combination join with straight line, so it will represent a linear combination, right, with respect to B dash and B. Clear? So that linear combination, it is the part of this set. And what are these linear combination? These are convex set and these are also the lower contour. We have decided on the basis of this level set. Here the level set with respect to the two-dimensional space in two quadrant. Here the level set in case of the equation of circle in four quadrant. So that circle represent the level sets. Clear? Which satisfy x square plus y square equal to a. All along all the circular values. All values will be equal to x square plus y square equal to a. Clear? For example, it is a is 1. For sake of for understanding, a is 1. Any all values when we plug x square plus y square, they will draw a circle when these are equal to 1. ऐसा ही है कि अगर फॉर एग्जाम्पल यानी लेट से मैंने आपको किया कि नाउ व्हाट विल बी द पॉसिबिलिटीज इफ दैट इज योर इक्वेशन ऑफ सर्कल, तो इट मींस कि देयर इज अ पॉसिबिलिटी दैट इफ योर x इज 1, so y will be 0. No choice is here. Clear? Then you will satisfy this condition. And vice versa, when your y is 1, so your x will be 0. Clear? So otherwise there is not possibility, because on the other values that value will not be equal to the 1. Either it will be less than 1 or it will be greater than 1, nothing else. Clear? So if you have to plot this circle x square plus y square equal to 1, that is your equation of circle, so it means that you need to substitute or plug those values which satisfy this condition, then you will be able to plot this unit circle. Clear? Which satisfy x square plus y square equal to 1, otherwise no. अब मैं for example अगर मैं यहाँ पे let's say I substitute 2, or for example if 1x and 1y, 1 square plus y square, so it's become 2, so it means के that value will be greater than 1. सही है? Clear? So that value will be greater than 1. So it means के these values are called upper contour set. Clear? And those values which give the answer less than 1, when we substitute the value of x and y, they are called lower contour set. Clear? यही कंडीशन होती है ना सर्कल की इक्वेशन की, कोई भी सेलेक्ट कर सकते हो. फॉर एग्जाम्पल हमने कहा नाउ द x स्क्वायर प्लस y स्क्वायर इक्वल टू लेट्स से 9. It is the equation of circle, it may be any constant. Clear? So whatever the values, so you know that if you have to plot the value of the, or you have to plot the circle, so it means that condition should be satisfied with each other, because it is kind of the equation. So you will have this kind of the thing again, and here you will satisfy x square plus y square equal to 9. अब now how you will compare? Now substitute the value of x and y. X and y, your choice variable. You substitute here the choice variable, and these choice variable give the answer which is greater than 9. So it is upper contour, and these give the answer less than 9. It is lower contour set. अब now what is the definition of the quasi-concave and the quasi-convex? We have decided that in case of the upper contour, these all are the upper contours. Clear? These all are the upper contour. And any value which is greater than 9, for example, it lie here. Okay? And another value, it is lie here. And when we join these 2 points with a linear line, it is called a convex combination. So any convex combination, because it is infinitely move in 4 dimensional or the 4 quadrant. आप कोई end नहीं है ना, ऐसी move कर रहा है. So any convex combination lie within that space. इसके अंदर lie कर रहा होगा. So it means कि it is called the यानी lower upper contour sets are convex. Clear? Any linear combination of upper contour set, it is convex. The function is called quasi-concave. And vice versa here, take any values which lie within that circle value of the circle. Clear? So what does it mean? Any linear combinations lie within that circular value. So these values are lower contour. And lower contour set, again it is the convex set. Clear? When the lower contour set are the convex set, we say that it is quasi-convex. Okay, it is quasi-convex.
So sir, कैसे कहना है? These are linear combinations of convex sets which are quasi-convex.
First of all, you have to decide what is the level set. ठीक है. Because देखो, in case of the multi-dimensional space, right? So you have to define what is your objective of the optimization. Clear? Being a consumer theory, optimizations is in case of the level sets, you have to define the IC curve. Clear? It is understood. Because IC curve represent our choice variable with different combination of commodity vectors. We defined it. For example, we are operating under the theory of the production. Clear? So what will be our level sets? Our level sets will be IQ. Clear? When you have two nation 1, nation 2, or the 2 production possibility frontier, clear, like this one, so it will be your level sets, right? Acha. Now you have to first of all define the level sets, because when you move in a multi-dimensional space, clear, so ultimately you will have different kind of the curve here, just try to imagine here. Okay, so for example, that it is kind of, for example, it is PPF kind of things.
Yes.
If you move in this way, clear? And similarly, this is kind of the IQ and IC curve, and so on. Clear? And now, when you decide to mark any level sets, clear? How you will decide the level sets? Ultimately, you will decide on the basis of your level of satisfactions, right? And that level of satisfaction which based on your constraint. What is your constraint? Constraint is your budget constraint, clear? And similarly, it is your cost constraint, right? In case of the production theory or in case of the theory of the consumption, right? You decide that now that is the level sets which is feasible and affordable for me, because indifference curve, now it is moved in open space, there is no end, clear? So that is called the indifference map, clear, which move in open space, there is no constraint, right? In case of the lower contour, for example, in this direction, there is a constraint of origin. What is the constraint of origin? कि now that you decide कि 0 and 0 you cannot move in the negative quadrant. सही है, तो that is your final constraint here, but there is no constraint is here. ठीक, so अब now you mark that is my level sets. ठीक है, in the case of the IC, so on the basis of level set you will decide के which region represent your upper contour and lower contour. Clear? Why? Because on the basis of the upper contour and the lower contour set, you will decide the nature of function, which is your quasi-concave or which is your quasi-convex. Clear? Ab now, for example, that is your upper contour we have marked with respect to this value. Clear? How can we, for example, we say that x alpha y beta, when we plug the value of x alpha and y beta here, you get the answer is, for example, equal to a, right? So any value greater than this one, so it represents your upper contour set, right? And any value less than this one,
Yes.
it is going to represent your lower contour set. Ab now, हम for example that level sets, clear, there are two sets, let's say uh, x and y, two values of the sets for sake of understanding belongs to capital X. It is two elements of the vectors that represent with capital X, both lie with x, sorry, both lie in x, capital X. Ab now, how you will compare this one? कि for example, it is your y. हमने कहा कि भाई y equal to, ठीक है, let's say in case of या whatever, हमने a ले लिया या y ले लिया, चले y ले लेते हैं, इसको हमने y ले लिया and it is equals to x1 alpha and x2 beta, for example, normal Cobb-Douglas production function. ठीक है, so अब for example these are the element of x. अगर मैं इसको यूं लिखता हूं, let's say upper contour को in masculine he represent by positive. So if I write this one, okay, y belongs to x, right, such that y at least greater than x, any value of x, y की कोई भी वैल्यू उससे बड़ी आ जाए आंसर x से, तो इट इज कॉल्ड अपर कंटूर. यहां पे मैं ये a भी लिख सकता हूं समझाने के लिए. क्लियर, राइट? और सिमिलरली इफ आई राइट दिस वन, फॉर एग्जांपल y belongs to x such that y less than equal to a or x, right? It is lower contour contours and it is upper. Clear? Up point is here कि these should be the convex set. Why? कि we cannot focus towards the non-convex set. We have decided because it is the part of property of the feasible sets. Clear? What was the property of the feasible sets? Property of the feasible set was that you will have a set which is by nature is convex. We have imposed this kind of the constraint ourselves, right? Clear, bilkul. So, for example, quasi-concave convex. Function. Upper contour sets are convex, subject to all values of x and y that belongs to x. The function is quasi-concave. Clear? And similarly, quasi-convex. Okay. Now the one important thing, it is necessary that every concave function will be quasi-concave. Not only one important thing, concave function will be quasi-concave. Clear? It must be quasi-concave. और से सुनना. And but vice versa is not possible. Repeat कर रहा हूं. Every concave function will be quasi-concave. But vice versa is not possible means it is not necessary every quasi-concave function will be first concave. It may be concave, it may be convex, or it may be linear. Now we will prove that. Okay, what I am saying that statement. Similarly, it will be that every convex function will be quasi-convex, but vice versa is not possible. Not necessarily true कि every quasi-convex function will be first concave, it may be convex, it may be concave, or it may be linear. Vice versa is not possible in both cases. Clear? So if, for example, I give you a questions कि now you have to prove that function is either the function is quasi-concave or quasi-convex. So if you have proved that your function is convex, so now it must be quasi-convex. And similarly, if you have proved that function is concave, so it must be quasi-concave. But if you have the quasi-concave function directly, and you have to decide what is the nature of function, so you cannot decide now it must be concave first. So there is the possibility other as well. It may be linear, it may be convex. Clear? ये possibilities हैं. Right? So now we will prove this one. Then we will move forward on the next topic.
Sir, what you mean is that it is not necessary for every concave function to be quasi-concave. It can be convex, concave, or
Or linear, yes,
हम ये prove करेंगे.
exactly. Okay. Now, in case of the Quasi-Concave, what we decided, what is the meaning of this one? Any two values which we have discussed previously, a and b, whatever, linear combinations of a and b, that is the linear combination 1 minus alpha, 1 minus lambda, and similarly that is greater than the min of a or min of b. What does it mean? For example, it is the functional value. Domain of function. Okay. We assume that a functional value of a less than functional value of b. What does it mean? Or a less than b. Okay. So that is fa. Similarly, this fb. So the linear combination will be here lambda what 1 minus lambda a plus lambda b. Clear? The linear combination will be this one. Okay, it is saying okay, now the min of a, so that is the value of a, initial value of a. So if we draw the line here, so all values it are represent the initial values of a. The value of a cannot be less than these values. Clear? And what about this one? And similarly, that line represent the minimum, at least the value of fb. All the values will be greater than fb if all the values lie above that line. Clear? Okay. So what does it means? So if we have the values in this region, put here and get any value. Clear? So it will be greater than, say, or equal to the min of this one, right? ठीक है. What does it means? If you have the min of this one, so you will select which value is minimum to satisfy your condition. Okay, so you will compare. For example, let's say it is 2, it is 3. Clear? So you will decide that all the values will be either greater than and equal to 2, not 3, because you have to select min of these. So which you will select? You will select 2 for comparison, not the 3. Clear? Min of this one, yani which value is minimum. If I write this one, max and FA and FB, so now again 2 and 3. So now you will compare with 3, not with 2. It is the meaning of max and min of this one, first of all. Clear? So now, what does it mean? All values, either they move in this direction or greater than min of this one. Because we have decided A is less than B. So functional value of A will be less than functional value of B. So that's why I am comparing with minimum value. Minimum value is FA, not FB in that. Okay, so all values which move in this direction, they are, when we substitute this linear combination value in function, so all values move in this direction and they are greater than and equal to min of this one. Clear? And similarly, all values move in this direction. Again, these are greater and equal to min of A.
Yes.
Clear? And all values move in this direction. They are greater than equal to this one. Clear? So what you have concluded here, if you have a quasi-concave function, clear? So initially it may be linear, it may be convex, it may be concave. It is not necessary it always be a concave. It is possibility it may be concave, but there is a possibility initially it is linear or it is convex. Then you satisfy this mathematical condition. So all values of f lambda, sorry, 1 minus lambda a plus lambda b, 1 minus lambda a plus lambda b are greater than min of f a, f b, it may be linear in nature, convex, concave. Okay, so if you have the vice versa condition, okay, now the b is less than a. Okay, so we can write here b is less than a. So again, b is less than a, so that will be b. Am I right? Clear? And it will be a. Clear? So what does it means? Again, that will be b and it is a. The conclusion is still same, or there is no need to move this. For example, okay, because we don't know the nature of function, maybe it is kind of the cubical function or the quadratic function. So when we move forward, either it is b. Clear? So the functional value of b is less than the functional value of a. There is the possibility after add and subtract. Clear? Right? For example, it is still a, it is still b, and again this one is a and this one is b. Just I change this condition and remove this one. I say the functional value of b, clear, right, is less than the functional value of a, for example. So then how you will compare? So in that condition it will be the min. Clear? If it is less than this one, it will be the min. So again the min condition, your functional value will be initially convex, linear or concave. Clear? So normally, for the sake of understanding, we move this one b and a, or this is a and this is b, and we assume that so there is no change in nature of function. So the conclusion is here, what every concave function will be quasi-concave, but it is not possible. It is not possible quasi-concave function will be concave. First, it may be convex, linear, concave. Up now, ultimately, when you have optimization, one important thing is that you add and subtract some functions. So simultaneously you have to deal with duality. The function simultaneously, one function in front of us is quasi-concave and another function we have quasi-convex as well. Clear? Constraint optimization, because when we talk about the constraint optimization, so in case of the budget constraint or the Lagrange, clear, so what you have, the cost function will be your convex or quasi-convex, and similarly the another function is your quasi-concave. Acha, why we are, another important thing, why we are assuming here कि our function is quasi-concave. देखो, quasi-concave and the quasi-convex is a weaker notation. Note कर लो. These are the weaker notation for optimization. अब now, what are the weaker notations? Because these are the weaker notations. Because in case of concave and convex, we are strict and we are not relaxed कि initially our function may be linear, convex or concave. So we relax our assumption and adopt a weaker notation कि our function is quasi-concave. And another important thing is that कि whenever you have optimization normally, or when you practically draw a function, any function, the function of sales, it is not necessary it always move in that direction. You will have a different inflection point in the function with respect to the time period. Clear? Sometime it decline, negatively slope, then increase and so on. So simultaneously that function with limited time period may have a different inflection point. Clear? Increase, decrease and so on. And another important thing is that if we assume whenever we start any business, okay, now my sales revenue is initially increase with increasing rate. Clear? Although in the short run, after certain time period, it will increase with decreasing rate, we have to assume that assumption as well. Why? Until and unless we assume that our function increase with decreasing rate, we won't achieve a maxima. That will be your global maxima, we have decided. Unique and maxima point with respect to its neighborhood. Right? So it means the function of sales, for example, it may like this one normally. So now observe this function. It is initially what? Convex, then concave. Clear? And similarly, you may have this one or this one like this one. Clear? So what does it mean? It is initially linear and then concave. And that condition you must opt or assume for maxima. If you operate still in that region, you won't have a maxima. Remember, yani you always assume that the sales revenue increase with increasing rate. So there is no maxima point. How you will decide your maxima? You cannot decide. Reason is that you never stop here. भाई तुम्हारी सेल्स अगर इंक्रीजिंग रेट से बढ़ रही है, यू इंक्रीज योर सेल्स एंड जस्ट पुट अप ऑल अदर वैल्यूज एज अ इनपुट टू गेट द रिजल्ट. ठीक है, यू विल नॉट नेवर स्टॉप देयर, वहां रुकोगे नहीं until and unless your returns start decrease. Clear? जब तुम्हारा रिटर्न डिक्रीज होना शुरू हो जाएगा, then you will decide कि where I have to stop. Clear? When your return start decrease after certain time period, then you will able to decide कि now that previous value was maxima. Clear? And after that value my sales revenue start decrease in the short run. Clear? Ab now I need further strategy of the sales to increase my revenue. In that region you never stop. अब अगर मैं ये कर देता हूं, फॉर एग्जाम्पल लेट्स से यहां पे यूं कर देता हूं कि फॉर एग्जाम्पल इट दिस वन, सो इट मींस कि इनिशियली आई अज्यूम दैट कि माय सेल्स इंक्रीज विद डिक्रीजिंग रेट. क्लियर? सो आई एम स्ट्रिक्ट to achieve maxima. Clear? Because initial my starting assumption is very strong, कि increase with decreasing rate. So the weaker assumption is that कि I relax, कि initially it may be this one, it may be this one, and finally I have to achieve the concavity of the function as well. Clear? Second important thing, with the psychological base or the rationality is here. Whenever you start a business, clear, so you assume that my sales revenue increase with increasing rate. ठीक है? That is psychological motivation as well, कि now I assume my sales initially increase with increasing rate. Because if you assume that my sales increase with decreasing rate, so it means कि psychologically you are demotivated, कि you from the starting point you assume that कि your sales start with decreasing rate, or after certain time period you will have a negative returns. Clear? So there are two strong assumption is here, कि first of all you relax your strictness of the assumption. Second one is that कि that is your psychological motivations, कि you assume that कि your sales increase with increasing rate initially. Clear? Second, in case of the cost you will be rewarded. Why? Because the cost is increase with decreasing rate, and then this one. So that's why you will have this kind of the cost function in your intermediate and other microeconomics book. So there are some strong assumptions, then you are able to plot this kind of the cost function. Clear? Because you need this one. Or another important thing, what is the second order condition? Second order condition is that mathematically your second derivative is negative or positive. Clear? So how your second derivative will be negative or the positive. It means कि second order condition will satisfy in this case, in case of the cost, your rate of return, yani your cost increase with increasing rate. Clear? Then the rate of return for next with respect to the next output will be negative. In that region, your rate of return is not negative, so your second derivative never be negative in that region. या कभी भी नेगेटिव नहीं आएगा तुम्हारा सेकंड डेरिवेटिव कर देख लो. क्लियर? अगर कोई फंक्शन ऐसा है जो इंक्रीज कर रहा है विद इंक्रीजिंग रेट, क्लियर, यानी इंक्रीज कर रहा है डिक्रीजिंग रेट, तो योर सेकंड डेरिवेटिव यहां पे विद रिस्पेक्ट टू द कॉस्ट, तो ये आपकी मिनिमा चाहिए, तो मिनिमा तो आएगा ही नहीं, तो व्हाट विल बी योर सेकंड डेरिवेटिव हियर, यू विल बी अ सेकंड डेरिवेटिव नेगेटिव. ठीक है, बट इन केस ऑफ द मिनिमा व्हाट इज योर सेकंड डेरिवेटिव कंडीशन, योर सेकंड डेरिवेटिव कंडीशन शुड बी अ पॉजिटिव, तो यू विल नेवर अचीव अ पॉजिटिव सेकंड डेरिवेटिव इन दैट रीजन. It is not possible. So theoretically, you have to assume that your rate of return is continuously increases. Yani cost continuously increases. So here you can achieve a second derivative negative. Here you will achieve a second derivative positive. तो देखो, तीन स्ट्रॉन्ग आर्ग्यूमेंट बताए मैंने. एक स्ट्रॉन्ग आर्ग्यूमेंट कि you relax your assumption of in case of optimization, because initially we assume that के nature of function may be anything. ठीक है, concave तो आना ही आना है. Second, you assume that कि there is psychological motivation in case of cost or in case of revenue or the sales and utility, whatever. Third important is that mathematically it is not possible to achieve a second derivative positive and negative, because for minima second derivative should be positive. So second derivative will be positive in that condition when your rate of the nature of function is increase with increasing rate, otherwise not, and vice versa in case of the revenue function. Clear? So now similarly you can write a condition of quasi-convex in this form. Max of p. Okay, less than max of A or B. So what does it means? And we have decided the functional value of A is greater than functional value of B. So it is right. A is here and B is here. Functional value is greater than this one. So which one is the max? Let's say it is 2 and this one is 1. Clear? So the value is less than max of this one, yani it will be less than with 2. ठीक है? So it means कि it move in this direction. All the values, if it is the linear combination lambda a plus 1 minus lambda b, and all values lie in this region. So linear, concave and convex. Linear, concave and convex. The function is Quasi-Convex. Okay, clear? Any question? पूछना है पूछ लें फिर आगे.
अभी देखना पड़ेगा सर.
दो दफा सुना है उस लेक्चर को, फिर सुना है क्या
सर अभी से देखना पड़ेगा.
वेरी ऑनेस्ट स्पीकिंग
पूरी तरह ग्रैप्स नहीं हो पा रहा.
वो एक दो दफा लेक्चर सुनने के बाद ना फिर समझ में आएगा क्वेश्चन क्या निकलता है.
ओके,
वो सेपरेटली
सही सही सही. क्योंकि बस ये है रीजन ये कि यार देखो पता होना चाहिए फॉर द अभी we will move forward towards the binomial distribution, normal and symmetric now. So first of all we will discuss the certain important assumptions, because in case of the papers you apply by binomial distribution लगा दिया, normal लगा दिया, but technically sometimes you are wrong. That's why you cannot publish your paper in reputable journals. वो आपको थियोरेटिकल आर्ग्यूमेंट की बेस के ऊपर ही आपके पेपर्स को उठाकर साइड में रख देते हैं, क्योंकि आप टेक्निकली आप रॉन्ग होते हो. तो आई विल एक्सप्लेन यू के व्हाट आर द सम टेक्निकल अजम्पशंस कि इन केस ऑफ द particularly when you working on the primary data sets, और जिसमें फॉर एग्जांपल यू हैव द qualitative data. Clear? Or sometimes you have the quantitative data, but you have to decide the nature of distribution first of all. कि what is your random variable natures? Either it is discrete or continuous, और कब it will be continuous और कब वो discrete होगा, then you can decide कि which kind of the distribution function you can apply here. Otherwise क्या होगा, आपने लगा दिया, आप लोग नॉर्मली क्या करते हो, व्यूज पे गए, आपने उठाकर क्लिक किया, बस जो फंक्शन से रिजल्ट अच्छे आ गए लगा कर दे दिया, आपको खुद भी नहीं पता होता कि क्या लगाना है क्या नहीं लगाना. तो देयर इज टेक्निकल. सेकंड, व्हाई यू टेक log of the function, exponential of the function, there are some strong assumptions कि वो भी हम क्यों ले रहे होते हैं. तो अभी वो हम डिस्कस करेंगे. देन फर्स्ट ऑफ ऑल वी मूव फॉरवर्ड कि देयर आर सम प्रॉपर्टीज रिलेटेड टू द फंक्शन. Properties of convex and concave sets. Function. Okay. Uh, what are some properties here? First of all, convex plus convex. Answer is convex. Right? When we have one function is convex, another function is convex. Clear? So it will not change the nature of function. Take the example of cost function. For example, when we add different marginal cost function, different total cost function in case of the multi-plant monopolist, clear? कि monopolist operating with respect to the different plant, let's say any pharmaceutical company is producing, for example, different antibiotic as well as some painkiller, clear, and both are operating with different operation or with different plant. When you add the cost function of these plant, okay, it is called the multi-plant monopolist. And similarly, in case of the horizontal or the vertical integration, let's say कि journal tires, clear, journal tires, for example, it's manufacturing the automobile as well as tire, clear. So it means कि the tires industry has another vertical integration with respect to the automobile industries. Both industries are going to run by General Motor for sake of understanding. Clear? So when we add these costs to, that is kind of the multi-plant monopolist and so on. Right? When we add these cost function, so there should be the assumptions that the cost is convex, both case of the plant or addition of that cost function should not be the change. Clear? Similar, another thing is that कि in case of the price discrimination, why I'm saying कि इसको डिटेल से बता रहा हूँ. In case of the price discrimination, sometime monopolist operating under a different pricing, it is not necessary that it always opt a uniform price structure. Take the example of the K-Electric, Swiss certain gas company, and the bundling. Clear? What are the bundling that in case of the any mart or the departmental store, you have the different kind of the bundles. What are the bundles? For example, you purchase a pack of 6, there is additional benefit of this one as well. Clear? And now on different food street, you have the different food packages or the deals. Okay, now purchase 2 tikka and 1 additional tikka is free for you. Clear? So this is kind of the bundles. So these bundling normally different business sector or different retailer offer you. Clear? And you decide to select that bundles. So these are not a uniform pricing. Why the per unit price of 3 tikka is different as compared to 1 tikka? अगर एक तिक्का परचेज करते हो you have to pay the more, or if you purchase 2 tikka तो 1 tikka is free, so you distribute the per unit price with respect to the 3 units, so your price per unit reduce. Clear? So it is called the price discrimination. We will discuss in detail when in case of the production theory of the production. So in that condition, ultimately, when the monopolist first of all will offer this structure of price discrimination, objective is that maximization of revenue, nothing else. ठीक है भाई, उसका ऑब्जेक्टिव यही होगा ना कि why वो इतनी lethargic प्रैक्टिस की तरफ जा रहा है कि he is offering a different price scheme और then he has to monitor कि भाई किसके ऊपर मुझे रेवेन्यू आ रहा है. तो अल्टीमेट ऑब्जेक्टिव इज टू मैक्सिमाइज रेवेन्यू, नथिंग एल्स. क्लियर? वरना यूनिफॉर्म प्राइसिंग इज it is very simplest way to increase your revenue or your charge your revenue whatever. So but some cases you are not able to avail a you are not able to increase your revenue because of the elasticity constraint. That's why he offers you different bundles. ठीक है, उसका एग्जाम्पल लो कि KFC है, sometime they offer different deals, package of the deals, overnight deals. These are kind of the bundles. ठीक है, if you purchase before 12 a.m. तो you have to pay more. After 12 and the midnight यानी till 2 p.m. या 2 a.m. you have a discount scheme or the different. सही है, most of the food यानी restaurant they offer these kind of the bundles. अब now in case of the cost, if we add, so for maximization of revenue, so the cost function either you will have the multi cost, so function of nature should not be changed. Otherwise if it change, so your optimization decision will revert. You cannot take a optimization decision. ठीक है, so the function of nature of the function should not be changed. Now second case is when you have the concave and concave. What does it mean? Simultaneously two revenues, function of two revenues, so the nature of function should not change. Concave. Up now what does it mean? What is the duality? Duality in case of the Lagrange, what? These are unconstrained optimization. First of all, unconstrained unconstrained optimization, right? Because your objective function is cost, that is in nature by convex. Your objective function is revenue or the profit, that is in nature by concave. Ab now, but if you have a budget constraint and the utility function, clear, and if you have the revenue function and the cost function, so simultaneously you are dealing with both functions. So in case of the consumer theory, what is your optimization? Your optimization is utility function, so it is concave, am I right? And what you need, subject to the minimization or with respect to your constraint of the budget, so it means कि this one, clear? So what does it mean? Your answer is concave, because you achieve a optimum level of solution. That is your budget constraint, which is by nature is convex, and it is your utility function. So what you have, your answer is optimum solution, optimum value of the function, it is concave. Constraint optimization, and vice versa is here, convex, concave. So answer is convex. So constraint optimization. Optimization.
subtract कर लेंगे.
Subtract, yes. Okay. अब now further properties that S and T are two convex set. ठीक है, these were related to the functions. Clear? Now every function, either it is concave, it is convex, based on convex set. Clear? Based on convex set. Remember, don't confuse कि what is the meaning of the convex set. Convex set means कि part of the feasible choice, variable feasible sets. On the basis of that convex set, we get a nature of function which is concave or which may be convex. Clear? बिल्कुल. So क्या किया था अभी हमने? अगर if you recall it, A and B, we take a linear combination. यही था. These are the values of domain, right? A and B. और हमने कहा था कि these domain values which give the answer of functional value, that functional value may be concave, linear, convex. यही डिसाइड किया ना हमने. ठीक है. On the basis of that functional value, we decide the nature of function further. Either it is quasi-concave or quasi-concave convex. ये हमने डिसाइड किया. But what about this one? We take the linear combination here, and that linear combination actually will be feasible set when these values belongs to convex set, nothing else. कि ये convex set से belong कर रही होगी, otherwise you cannot prove, you cannot take the linear combination. ठीक है, ये convex set होगी. यानी convex set means कि ये ऐसे arrangement में lie कर रही होगी which will have a proper geometrical shape. ये मतलब हुआ. They have the arrangement, यानी these elements of set arranged in that way which have a proper geometrical shape.
सुनिए ऐसे कर.
No. Proper geometrical shape means कि they may be square, they may be these, ठीक है, or oval and circle. Clear? These are the shape of convex sets, right? अब ये convex sets हैं. इनमें से मैंने कहा अब यहाँ पे set क्या है? Collection of element. यही कहते हैं ना भाई, set is what? The collection of elements, and these collection of elements are arranged in that way, in the form of circle, in the form of square, in the form of oval, in the form of triangle. Clear? ये है तो हम कहते हैं कि these are the proper geometrical shapes. When you have these proper geometrical shape, we call it convex set. Why? क्योंकि अब इनमें कोई भी elements, element A select किया, now this is element B. When we join these with linear line, so वो इसी के अंदर रहेगा, इससे बाहर बियॉन्ड नहीं करेगा.
So sir, वो फिर quasi convex होगा ना?
अभी नहीं, मैं आगे आप सो गई थी. ठीक है. ठीक है, तो ये इसी पे होगा. अब नाउ ये इसी पे लाई कर रहा होगा. देखो कहने का मकसद ये है कि अब ये अरेंजमेंट ऑफ एलिमेंट्स है यार. फॉर एग्जांपल मैं तुमसे कहूं कि नाउ कलेक्ट सम इंफॉर्मेशन रिलेटेड टू द CGP ऑफ स्टूडेंट. ठीक है, तो दिस इज द कलेक्शन ऑफ सेट एलिमेंट. यही हो गया जिसको हम कहेंगे सेट ऑफ CGP ऑफ स्टूडेंट. यही होगा. अब मैं तुमसे कह रहा हूं नाउ द सेट ऑफ CGP ऑफ स्टूडेंट. तुम्हारे पास 100 स्टूडेंट थे. क्लियर? एंड यू हैव सेलेक्टेड डिफरेंट वैल्यूज, मे बी पॉसिबल A, B, C एंड स्टूडेंट 1, 2, 3 दे हैव द मल्टीपल वैल्यूज, किसी की 3.2, 3.1, 2.5 एंड व्हाटएवर. क्लियर? अब मैं कह रहा हूं सेलेक्ट एनी टू वैल्यूज, 2.1 and 3.2. Clear? Or take the average. Average should be the part of this set. Repeat कर रहा हूं. देखो मैंने तुमसे कहा कि CGPA CGPA ऑफ स्टूडेंट, क्लियर, स्टूडेंट 1 की मैंने कहा फॉर एग्जांपल 2.6 आई थी, फिर 3.2 एंड सो ऑन, दीज वैल्यूज लाए, लेट्स से मैक्सिमम वैल्यूज जो आई वो 4 तक आ रही होगी, ऐसे ही है ना, ठीक है। ये मैंने कलेक्ट किया,
सेट हो गया,
ठीक है, एक सेट हो गया, द सेट ऑफ CGPA ऑफ 100 स्टूडेंट।
इसको हम कॉन्वेक्स सेट भी
अब सुनो, अब मैं तुमसे कह रहा हूं कि सेलेक्ट एनी 2 वैल्यूज, मैंने 4 लिया और यहाँ पे 3.2 ले लिया, इन दोनों का एवरेज लिया, ठीक है। क्या किया, कैसे एवरेज लूंगा, वी हैव द वैल्यू ऑफ लैम्डा, ठीक है, लैम्डा इज वेट, हाउ मैनी वैल्यूज ऑफ 4 लाई हियर, वेटेड एवरेज है ना, हाउ मैनी वैल्यूज ऑफ 3.2 लाई हियर इन दैट सेट, तो इट मींस कि आई विल टेक वेटेड एवरेज, दिस इज द काइंड ऑफ द वेटेड एवरेज ना, जो मैंने अभी लैम्डा एंड 1 माइनस लैम्डा, इट इज काइंड ऑफ द वेटेड एवरेज, लीनियर वो ले लिया मैंने। अब दैट वेटेड एवरेज ऑफ लीनियर वैल्यूज, इफ इट लाई, जो आंसर आया अगर वो इनमें से कोई है तो मैंने कहा भाई मेरा कन्वेक्स सेट था, अगर जो आंसर आया इनमें से नहीं आया, क्लियर, तो इट मींस कि मैं कहूंगा कि दिस इज नॉट द पार्ट ऑफ द कन्वेक्स सेट, यानी कोई एक आउटलायर है व्हिच लाई बियॉन्ड दीज वैल्यू। अब उसको मैं ज्योमेट्रिकली हाउ आई कैन रिप्रेजेंट, देयर इज बेसिक द रूल ऑफ थंब कि आई व्हेन वी अरेंज और वी प्लॉट, ठीक है, दीज फिगर्स, अगर वो एक प्रॉपर ज्योमेट्रिकल शेप बनाकर दे रही है मुझे, तो इट मींस कि वी कॉल दिस इज द पार्ट ऑफ द कन्वेक्स सेट। अगर वो ज्योमेट्रिकल शेप नहीं बना रही है प्रॉपर्ली, यानी यू विल हैव द इररेगुलर शेप लाइक दिस वन, फॉर एग्जांपल जो मैंने कहा था कि फॉर एग्जांपल दिस वन, that is kind of the irregular shape, you cannot define by any geometrical shape, clear। तो अगर तुम्हारे पास ये irregular shape है, ये इस तरह का irregular shape है, तो it means कि इस तरह arrangement हो रही है, तो we call it कि it is non-convex set, ठीक है,
पुराना लेक्चर है ये, रिपीट कर डिफिकल्ट है,
ठीक है, it is not convex set। अब नाउ, अब इसके ऊपर आई कैन डिफाइन अ फंक्शन, मैं डिफाइन कर सकता हूं ना भाई, मैंने कहा कि भाई फाइंड f ऑफ 3.2, जो भी फंक्शन है, मुझे नहीं पता अभी फंक्शन क्या है, स्क्वायर फंक्शन है, क्यूबिकल फंक्शन है, व्हाटएवर द फंक्शन, क्लियर, फाइंड दिस वन, ये मैंने सेट लिया, उस पे एक फंक्शन के साथ अटैच कर दिया। नाउ हाउ आई अटैच, फॉर एग्जांपल आई अटैच विद एनी स्क्वायर फंक्शन, कॉट डगलस फंक्शन, मैंने कह दिया भाई ये 0.5 और ये मैंने 0.5 ले दिया, इसके साथ अटैच कर दिया, फॉर एग्जांपल फाइंड f ऑफ 3.2, क्लियर, यहां पुट किया, निकाल लिया आंसर, एक आंसर आया मेरा। अब मैंने ये कह रहा हूं कि भाई फर्स्ट ऑफ ऑल तो मुझे ये प्रूव करना है दिस सेट इज कन्वेक्स। अब कन्वेक्स सेट में ड्रॉ अ फंक्शन which may be concave, linear, convex, वो कोई भी फंक्शन ड्रॉ कर सकता है। अब इन केस ऑफ ऑप्टिमाइजेशन मैं अज्यूम कर रहा हूं कि इस कन्वेक्स सेट से द नेचर ऑफ फंक्शन शुड बी कोसाई कनकेव और कनकेव, और इन केस ऑफ मिनिमाइजेशन आई अज्यूम ऑन द बेसिस ऑफ दिस कन्वेक्स सेट माय नेचर ऑफ फंक्शन विल बी कन्वेक्स और कोसाई कन्वेक्स। ये मैं कह रहा हूं कि मुझे अज्यूम करना पड़ेगा, ठीक है। तो अच्छा, अब एस एन टी आर टू कन्वेक्स सेट्स, तो उसमें मैं ये कह रहा था कि फॉर एग्जांपल लेट्स से कि एस इंटरसेक्शन टी कन्वेक्स सेट है एंड S plus T convex set है, and similarly A S plus B T, it is convex, and product of two convex set is convex. So product of two convex set, it is convex, and intersection of two convex set, it is also convex. Summation of two convex set, it is also convex, and any scalar combination, sum of scalar combination is still convex.
सर वो आपने जो अनकंस्ट्रेंट ऑप्टिमाइजेशन बताई थी वो लैग्रांजियन फंक्शन जो होते हैं वो अनकंस्ट्रेंट
नहीं, लैग्रांजियन फंक्शंस तो कंस्ट्रेंट ऑप्टिमाइजेशन है. एग्जैक्टली, व्हेन यू विल हैव द लैग्रांज तो इट इज द कंस्ट्रेंट ऑप्टिमाइजेशन है. अनकंस्ट्रेंट ऑप्टिमाइजेशन व्हेन you have a maxima minima through first order and second order condition, so it is unconstrained optimization. Or first of all, Lagrange function is always applied in case of equality of the constraint. In case of inequality you cannot apply the Lagrange. ठीक है. So there is another concept, Hahn-Tucker condition, then we will discuss in detail. KU and KHUN, Hahn-Tucker condition कहलाती है. That is the case for inequality. KHUN. Okay. So the next is there are some important conditions. टाइम क्या हो गया? 2:15. कब स्टार्ट किया था हमने? कमिंग क्लास में कर लें बाकी
पैमाना चलक गया
है.
कासा जो है ना
अच्छा, ये क्योंकि थोड़ा सा और डिटेल है अभी इसके अंदर ना.
समझ नहीं आई.
कॉन्वेक्स सेट वाला लेक्चर है जो पहले सर ने दिया था ना,
हाँ, उसमें से देख लो. उसमें
उसको कनेक्ट कर रहे थे.
ठीक है. चलें, थैंक यू सो मच.
Thank you very much.